Hey guys, so today we are going to talk about finding the square roots. We are going to start talking about area first. So area means how much space something occupies. So for example, if I had a rectangle like this. Okay, so then it is 5 units tall, and 7 units long. And these are little squares. So to figure out the area, all we have to do is figure out how many squares fit into this bigger rectangle, these tiny squares. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay, so there's 35 little tiny squares that fit into this. Now there is a shortcut for this. All you needed to do was multiply the length and the width together, and that will give you your 35. So if I had another picture, like let's say this guy over here, and I wanted to find the area, all I have to do is count how many squares tall this is. So 1, 2, 3 squares tall, and how many squares this way, and that's 1, 2, 3, that would be wide. And then to figure out the area, I don't have to count all the cute little boxes, we can just multiply these. So that will be 9 units. Now, these guys are slightly different. One of them is a rectangle, so that means that the side lengths are different. One of them is a square, which means that the side lengths are the same, and this is what we're going to be focusing on, is the square. So on a side length, if you notice on a square, this distance and this distance and this distance and this distance are all the same amount, and that's what's special to a square. So we call, if we're just talking about a square, one of these will be called the root. So this guy is just called the root. And the root is what all of the side lengths are, right? Because they're all the same. So it's a really special number. So we call this guy the root, and then this number inside here is actually our area. Okay. So now we have more squares and more side lengths. So here I have a square that has a root of 2, so that means that each side is 2. The area inside of my square is going to be 4. So my area, my big number is 4, and my root, my little number, is 2. Then here I have my root, which is 1, 2, 3, 4, 5, 6, 7. Now it doesn't matter what side of the square you write your root on, but that is my root, is 7. So to get the area, we multiply 7 times 7, because that's how you do area. That's a shortcut, and that will be 7 times 7 for the roots, and that will give us an area of 49. Sorry about the bell. Okay, now the same thing here. Our root is 1, 2, 3, 4, so that means all of the square has a side length of 4. To get the area, we would multiply 4 times 4, and that will give us 16. And again, if we wanted to, we could count all of the little squares, but we don't have to with our shortcut. Here, let's see, our root is 1, 2, 3, 4, 5. So if our root is 5, then all of our side lengths are 5, and the area, the big number in the middle, is going to be 25. Here we have a root of 1, 2, 3, so that's like what we did already. Then that means that the area is going to be 3 times 3, which is 9. Here we have a root of 1, 2, 3, 4, 5, 6. So that means all of the side lengths of this square are 6, and 6 times 6 is 36. Okay, so what we did is we took our roots. So let's say that we didn't know what the root is. Well, we could use a variable for that. So if we have a variable, let's pick x. What we did to figure out the area is multiplied it by another side length. Well, those are all the same side lengths because it's a square. So we're going to call the other side length x because they're the same. And then that gives us our big area, right? Well, we don't have to write x times x. We could use a shortcut. There are 2 x's, so we could write it as x squared is equal to our area. Okay. So, the opposite of squaring something is called taking the square root. So this symbol is the square root. And remember, the root of the square is just one of the side lengths of the square. Okay? So here we have given you the big area, and you need to find the root. So what you do is you take your cute little calculator, and you're going to press the square root button, which is over here by the squared. Oh, you can't see it. Up here. Oh, I have to turn it on. Sorry, my bad. Okay, so you're going to press second, and then right here it's got x squared. And then you're going to type in what our area is, which is 25, and then press enter, and there is our root, is 5. So our root, or our side length, is 5. The same, we're going to keep going. And I know that we did some of these up here, but we're going to practice using our calculator. So let's do 9. We're going to figure out the root of 9, if 9 is my area, and the root is 3. So the root of this guy is 3. And then we'll keep going. So second square root 100. So the root of 100 is 10. So this is called a square root because our picture is a square and we're figuring out what the root is. So what number multiplied by itself will give us our area. Okay, so then we're going to do the same thing with 16. Second square root 16, and that gives us 4 for our root. The same thing with 64, second square root 64, and that gives us 8. And the square root of 1 is 1. There it goes. Okay, so now what we're going to do, we're going to do this page. We're going to do some of the odds. Okay, now not all the time is our square root perfect. Like 30. Well, 5 times 5 is 25, and 6 times 6 is 36. So this guy is not a perfect square root. So perfect square roots are just whole numbers multiplied by themselves. So squared, if I take 1 squared, then that gives me 1. If I take 2 squared, that gives me 4. If I take 3 squared, that gives me 9. So this would be 1 times 1, 2 times 2, 3 times 3. 4 squared is 25. 5 squared, so remember that's what we're doing with our area, multiplying our roots. Ooh, 4 squared is not 25. 4 squared is 16. 5 squared is 25. And then 6 squared is 36. So if it's not one of these numbers for our area, we always put our area inside of our square root or our radical symbol. Then we cannot get a perfect answer or perfect root. Okay, so these are perfect squares and these are perfect roots. So it's going to be some sort of decimal. However, this time for this unit, we're going to talk about reducing radicals. Now, our calculators can reduce radicals for us, and if you don't have access to this calculator, you can use the Desmos calculator online. So all we're going to do is we're going to type in what we see. So second square root of 30, just like we did on the other page. This 30 is our area, and we're trying to figure out what the root or the side length of our square is. And it is nothing that we can simplify. Well, that was fun. Okay, so the square root of 30. Now, we could press the fraction to decimal button and say that technically the square root of 30 is 5.4 or 5.5. So that means 5.5 times 5.5 will get us really close to 30. Unfortunately, it won't get us exactly 30 because there's these numbers in our decimal as well. So let's talk about the next one. Let's ignore this negative for a second. Okay, so now we have the square root of 252, so we're just going to type that into our calculator. Square root of 252. We're just pressing buttons in our calculator today and practicing. Now, this answer it gives us is 6 root 7. This is what we call a reduced radical. And we're going to be working with these guys a lot. So we're going to write 6 root 7. Okay, the next one, we're going to type this guy in. There's a cute little negative there. We're just going to type that guy in and see what happens. Negative 175. When we type it in, we get an error. Here's the problem. Remember our cute little squares? Our squares say that it's a number times itself gives us the area. Well, these guys are all positives because 2 positives multiply together to give us a positive. Well, what about 2 negatives? What did 2 negatives multiply to give us? Let's try 6. Oops, this pen. Negative 6 times negative 6 is positive 36. So it doesn't matter if we have a negative or a positive, we'll always get a positive area. So the thing about area and squares is that these two numbers that we multiply have to be identical, or else it's not a real square. In order to get a negative number, and you have two numbers, you need one to be negative and one to be positive. This square root of a negative number is actually called an imaginary number. And we're not going to be talking about those this year. All you need to know is if you type your square root into the calculator and you see this domain error, it means you have an imaginary number and you're just going to write I, because I stands for imaginary number in math. Later on, you'll work with this number and you'll do math with it. Okay, let's try number 7. Second square root 320. And that equals 8 root 5. So it's reduced to 8 root 5. And we're going to teach you how to do this by hand coming up. For now, just write it down. Okay, now let's talk about this negative. This negative is just going to hang out in front. He actually means the opposite of your answer. So we're going to let him hang out in front for a second. Okay, so we're going to take the square root of 245. And that is 7 root 5. Okay, so 7 root 5. Now, all negatives mean opposite. Remember when I told you back at over here that if we have the same sign, we could get positive numbers. So if we have two negatives, we could get a positive. And if we had two positives, we could also get a positive number. So that means that when we take the square root and we're trying to figure out what our side lengths are, we're not sure if they're going to be the negative 2 answers or the positive 2 answers. So in that case, mathematicians came up with a symbol, and it's called a plus-minus symbol. And it means both the positive version of the answer and the negative version of the answer are answers. So for all square roots, we are going to have a plus-minus sign that goes in the very front. So we could have positive versions of the answers or negative versions of the answers for all of these. Okay, so we're going to just put that little symbol there. Or what you could do is you could write, well, we're going to have positive 7 root 5 or negative 7 root 5. Okay, so these are your two options for answers. You can write the plus-minus symbol and just one of them, or you could write out the positive version and the negative version. Okay, so 11. We'll keep going. Second square root 512, and we get 16 root 2, but we could have the negative version of 16 root 2, so we put plus minus. Now, the reason on this one it doesn't matter is because this means opposite. So we would do opposite of a positive, which is negative, and opposite of a negative, which is positive, so it keeps a negative and positive, and it doesn't really do much. You just need to know if you see this, you can still have two answers. It doesn't mean that one answer is the rule. Okay? Then we're going to keep going. Second square root 8, and that gives us 2 root 2. And remember, it's a positive or a negative 2 root 2. So that means that I have a square. One of my side lengths is 2 root 2, and the other side length is 2 root 2. Or I could have a square with one of my side lengths being negative 2 root 2, and the other being negative 2 root 2. Either way, my area of both of these squares is the square root of 8. Okay, that's what this means. And lastly, we have second square root negative 27. Oh no, domain error. That means that we cannot take the square root of a negative, so this is an imaginary number. Okay, that's a lot of information. If you have any questions, let your teacher know. You need to do the backside of this worksheet as well. You're just plugging in the numbers and seeing what you get for your answer. Have a great day. Bye, guys.